Hello! I think we're live. Hopefully it's all working. Good afternoon, everyone. Welcome to finally building the Darwin Evo. It's been a long time coming. Well, I've already built one, obviously. Now we're doing it live. So, hello. Hello, Lars. 3D Musketeers. Hello. 3D Printer Wolf Engineering. James is here. Hello, 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 hello. Let me know if everything's working. Sounds like we should be good. Cool, 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 cool. Good afternoon, good morning, good evening, good day. Hello. So, I do have to let you know that this stream is technically sponsored. So, the down low is LDO have provided a bunch of the parts. Obviously, like LDO motors, provided motors. E3D have provided hot end and nozzles and stuff. And Jo Prusa is paying me to make this build for him. So those are technically our three sponsors. Now you know. That's pretty much it. Oh, and Joe's also going to be making a donation to Sanjay Mortimer Foundation, equal to that of the first printer that I made as well. That's the situation, just so you know. Now you know. There are no instructions at all. Well, there's kind of, I guess, original Darwin instructions, but probably not super useful for my specific build here. So I'm going to be doing it off of CAD. Now, hopefully this laptop doesn't go to sleep. So, hopefully, there you go. So, basically the idea is, so this model is open source. The whole Fusion 360 file is available on printables. I'm pretty sure I put the link down below for that. So you can go check out the model and interrogate it for yourself. I'm going to be kind of following that through for the assembly. That's the plan. You can also make a donation to Sanjay Mortimer Foundation via the PayPal link below. It won't track or anything on stream. I think that would have been fun, but it's not set up to do that at the moment. So if you want to make a donation, you can do, but I won't know about it. And it won't be tracked as like, this is how much we raise for this set of streams. Unfortunately, that's the situation. But if you want to, you still can, of course. Is there anything else we need to know before we start? Probably not. Oh, yes. So the other purpose of the live stream is to test the bill of materials. So on printables, I have again linked the full bill of materials, which is a list of all the parts needed, which should be this lot. That's all available. Again, you can go check it. You can buy, there's like links for everything. All the quantities and stuff are all there, so you can work out everything you need. This is basically that list of stuff in a box. So if at any point I go and grab stuff from a shelf and I don't note it down, you need to yell at me, because that means the bomb probably needs to be changed. Everything we need should be in this box. Well, excluding the rods, the bed, like there's some other stuff that doesn't fit in the box. But hopefully I won't be going to get screws and stuff from anywhere else. It should all be here. Now the downside to that, of course, is it's not very organized. It's all just lumped in the box as it arrived. So yeah, could be a little bit difficult finding what we need at the right time, but I'll do my best and hopefully it'll be good fun as we go. I'm not going to be obviously doing this all in one stream. This is going to be going over probably a number of streams, maybe a number of weeks. I don't know exactly when I'm going to have time to do them. I'm aiming for at least this time each week, so hopefully Thursday every week will be a live stream. And then I might try and squeeze more in as well, make sure you're subscribed, and then you'll hopefully get notified. You know, the little bell notification. What's it? Make sure notifications are enabled on your phone, all that kind of stuff, and then you'll be notified when the stream goes live, and then you can join in. Or watch back afterwards. Part of the reason for doing this is to make some instructions. As I said, there are no written instructions. I'm following the CAD, so hopefully I can translate some of that CAD information into something that's useful that people can follow if they also want to build one. At some point in the future, I'm hoping to have kits available from LDO. I'm sure you know LDO Motors, who make like the Voron kits and stuff like that. And of course, motors for loads of printers, as well as loads of other parts for printers. So they may be doing a kit. It's not guaranteed, it's not certain at the moment, but we are trying to work it out and see if it's possible. Obviously, the demand is very important in that, so I think I put it in the description as well. There's like a sign-up link on my website. It's just for notifications, and it allows me to kind of count how many people are interested in getting a kit. Yeah, I put in, if you're interested in getting a kit when they come out, you can sign up to be notified here. The price is not known yet because A, the BOM is not fully confirmed, and B, we've not worked out the full configuration for the LDO kit either. So we don't know what final pricing is going to be, but it's going to be in the region of Voron 2.4 pricing. I guess that's the estimate, but plus or minus quite a bit because we don't know yet, basically. With that being said, I think we're ready to start. Maybe? Probably? Oh, I get to show you some cool stuff as well that I've been working on. So, does anyone have questions before we start? If not, we're going to get into it. There's several hundred heatset inserts in this build. So, we're going to be starting with that today because you kind of need them for the first part of the build anyway. Right, doesn't look like there's any questions. I think we're on ultra low latency, so hopefully there's not too much latency between me asking stuff and anyone being able to respond. Right, okay, let's get into it. So, this is all the CAD. As I said, you can get it via the link on Printables. It's all open source, so it's all totally free. In here, everything is kind of set up in a sort of assembly order. It's not perfect, but it's mostly the assembly order. So as you can see, you start with this, and as you just, oh, wrong button, my bad. Start with this, and then this, and then this, and then this, and then put these in, and then this, and then this, and then this, and then this, and then this. See, so it's not perfect, but you kind of, it's the outer frame, then the Z motor assemblies, then you put the top bit on the top, then you do the bracing around the side, and then you do the bed, and then you do the gantry, and then you're kind of there. So it's kind of simple, but hopefully I'll be able to walk you through a little bit more in detail as we go. The first bit is probably the most difficult of all the bits. Not because it's kind of a complicated assembly, it's more just because you need to get heatset inserts in the right places, and because the orientation is not really very obvious until you're further through the build, it's very easy to have stuff rotated the wrong way, the heatset's in the wrong place, and then they're on the wrong place on the final build. So I'll try and get it right first time, but I'm not going to guarantee anything. I'll do my best. As I said, because there's no instructions, I'm kind of doing it a little bit from memory, the one that I did at the end of last year, and a little bit, obviously, predominantly from this CAD. So, with all that said, let's make sure I don't grab this wire in a... Oh, it's getting caught on something. Could you add something to the files to show the correct sides? Potentially. But all the blocks are identical. So if I add something to the sides of the block, then it's no longer the same block all the way around. At the moment, you're just printing 8 of the same block. I suppose we could have 8 slightly different blocks. I mean, so this is... Okay. This build was only ever intended for me to make one. So it was designed to be auctioned as Smurf. I was going to design it, build it, and that's kind of done. But after, like, it had quite a lot of popularity from being at Smurf, and lots of people were interested in it, and it's quite an interesting build, I think. So it kind of became a little bit more popular than I was expecting. So that's why we're now going into doing this build and do some kits. So the design is not necessarily intended for that purpose. So there are some stuff that's a little bit weird and maybe could do with improvement, but it's intended to be like the first RepRap. If I start modifying it to have like loads of assembly aids and assistants and stuff, then you kind of lose a bit of that original joy. So we may have like a V2 maybe for like Smurf this year or something. I don't know. That's not confirmed. That's literally just a thought out of my head right now. So stuff can change, stuff can improve, but this is the current situation. Has Ellie's been shipped yet? No, it has not. I'm awaiting. So Ellie's shipping me a big box so that I can put the printer in and then it will go off. I've not received the box yet, so I still have the original printer. So I have lots of these around at the moment. I really hope I have not miscounted the number of blocks that I've printed. That would be not a great start. Ah, I see it. Ta-da! So one thing I'm going to try and do that I think is going to help is use some masking tape and try and label these up in some fashion. Because that way, as I'm putting heatset inserts in, I can make sure I get them in the right place and then get those pieces into the assembly in the right place. So when printing these, you do need to make sure they're quite high perimeter count because you use little heatset inserts as grub screws, basically. You can check on here which way is front because it shows on the CAD. Oh, you can't quite see that for some reason. It's kind of cut off. Right top corner, you see it's set to front. So this is front, label top right is the front of the printer. So we've got front left, front right, rear left, rear right, and then top left, top front left, top front right. You get the picture. They are all identical, rotationally symmetrical, and there is obviously 8 in total. So I think if we get some masking tape, so we want, this is maybe not the best plan. What can we stick it to that's going to work well? So we want bottom, front, left. Maybe do upper. Does that make more sense? Upper, left, front. And then we need an arrow to point which way is actually front. and then we stick that over the hole in the middle, and that'll hopefully upper right front. It's going to take longer than expected. Upper left rear. Upper right rear. Upper left front, upper right front, upper left rear, upper right rear. Is that one? That was the wrong way up. So the orientation of these also matters because they're not symmetrically rotational symmetric. What's it? So as you look on here, you can see this front left one has that central bit at the top, and that's what always needs to face forwards. So this one is around the wrong way. This one needs to go this way. This one needs to go this way. Upper left rear, upper right rear, upper left front, upper right front. I feel like I'm going to get those wrong. That needs to go this way up, this way up, this way up. I'm pretty sure the top is the same. Yeah. So now we're lower right front. Lower left front. Lower rear right. Lower rear left. Maybe not the best notation because there's lots of L's and R's. The right front, lower left front, lower right, lower rear left, lower rear right. I think I've changed the notation around a little bit. Hey, it'll do. I can't really show you stuff very easily on the camera. They just kind of look like this. This is what I've done. You see this? I think the focus is in a weird place. Hang on a second. Yeah, the focus was right off at the edge of the screen. Hopefully now it will work. There we go. Lower left front. Hopefully you can sort of see that. Not super obvious. But it should help a little bit with getting the inserts in the right place. Speaking of inserts, we're going to need to find those in this huge box. I'm not going to go through the parts now. We'll obviously go through them as we go a bit. But I went through the bill of materials, so the parts we're using in the previous stream. So if you want to know a bit more, you can find that there. I might have to organise this a little bit better at some point, because otherwise we're going to spend half of every stream digging through a box of parts. May not be the most entertaining thing. We've got some M4 inserts. So in this build, I've used, for the M3, I've used the Voron spec, so the M3 by 4x5 or by 5x4, whatever it is. And then for the M4 and M5 ones, they're the CNC Kitchen variety. Aha! Wow, did I label everything? Bloody hell. Cool. That'll help. Well on past me. Good job. Now we need my heatset insert press. This is all the printed parts for the build. We will be using every single thing in there, pretty much. I'm not going to share how much he's paying me for the build, but it's irrelevant. Just a standard rate that I do for building printers for people. So we've got to go out with this. Now, unfortunately in my setup, the cable's a little bit short. As I said, the cable is a little bit short. What can I prop that up on? Ballistic tech, yes, all four. Well, there's actually 8. Oh, I've now missed one because I've knocked it off the desk. Where's that gone? I didn't even see it fall down. What? That's very confusing. Did anyone... Oh, I think it's gone the other side. Upper rear. front, left rear, right rear. So this is what I mean. I've counted out the whole bill of materials into bags. So hopefully we can validate the parts that are needed for the build. So this right here is VLMP Pro. Ta-da! So we've got aluminium base, this really cool configurable mass option in the back, an improved adjustment mechanism for positions. We might be doing this for quite a little while, so everyone get comfortable. Oh, I made these recently as well. Stackable hex trays for parts. Very happy with those. Anyway. That's that one there. So it's there, there, and then here. That should be... I think that's right. So it's basically one for each of the rods in the various directions. So we've got one for Z, one for X, and one for Y, and those are the three rods, rods, smooth rods, which go through that particular block. Again, try and keep the front consistent. I mean, you could put heater inserts in every single hole, but you'd have way too many and you'd end up using 5 times the amount you need. Which is probably not ideal. So that goes there and then here. So this was front. Front here and then here. That should be that side. I think any in the back, so that's the front 2 blocks. And then we've got the back one, so the back one they go at the rear at the top. And I really like the way you use set screws for this build. Yes, for this, I think it really helps in terms of like adjusting the frame and getting it just right, because that can be quite difficult with the old frame design, I believe. Lower right, left, lower rear, left, lower rear, right. Ooh. Flush, nice. And then the last one on here, that's there, so that's at the back, and then this is here. So that's the lower blocks done. Now we do the upper blocks. So we're going to have to, on the CAD, we'll have to scoot forward a bit. I think it's this one. Oh, did I have that? Oh, I think I've done it wrong. Front. Let's just check them. Is this, this. That one's this, this. That one's this, this. This one is this, and this. Yes, okay, they are right. Good. Did wonder for a minute. So yeah, let's zoom forward a little bit to get the upper frame. Again, making sure to get the orientation correct. Now, they might not be in here at this point. No, this one definitely needs 3. Oh no, it's at the rear, isn't it? Yes, this one needs 3 extras around this area. Maybe we'll do that one first. Upper rear right. This part is a bit confusing, yes. I do want to make it easier. I mean, with them labeled, it's actually not that hard. Perhaps we could find an alternate way of doing it. Yeah, so this needs 1 in the place of the screw and 2 in these as well. So these upper blocks do have quite a few extra in. Let's put these in a little tray. It's going to make it a bit easier, I think. I mean, as soon as I start marking them with dots and stuff, all the parts, all the corner blocks become different parts. This is the difficult bit. If I'm going to mark them, I might as well just remove all the holes that are not needed and make all the blocks unique. I've made a note. So now we do this one. I mean, it's not that difficult. I mean, for printed parts, that added complexity really isn't a major problem. So that should be good for that one. One top, one rear. Oh, we need to do the rear one. I think maybe the best solution will be to have make them custom blocks, as was suggested. But instead of having like the full through holes in a lot of these plates, that was hot. Instead of having the full through holes, just have it like 1 millimeter deep, so it still gives like a little hole feature, but it's not actually a deep hole that you could put an insert into. I think that way it'll still look quite good, but without being quite so obvious. And it'll just make it easier to make sure you know where the inserts are going. But as I said, this is by far the most difficult part. In fact, I think it might be the only difficult part. From memory, if I recall correctly, hang on. We've got to get our front the right way around. Have I just done... It's very important. Front has to go the right way. From memory, this is the only part that really requires instructions, as in to get the things in the right place. Everything else just kind of goes together and pushes together. Ah, my ears can finally rest. I was doing a print on the K1C, and the fans on that are, well, the whole machine is just incredibly loud. One was of course that. Okay, cool. That's that one, and now the last top block. Oh, it went to sleep. I wonder if it needs more shaking around. Oh, it's going to take a little bit to heat up now. Pretty much as soon as we get the frame, these corner blocks, the whole frame just goes whoop. You start putting the rods in, that's a frame, corners, frame, bish bash boss. You got a printer. Front, so that's this one here. That's the empty one here. I really like the max acceleration velocity testing you've done with the 2.4 build, I think. Then you showed in the Delta printer video. Any chance of a dedicated video? My video plans are sort of on hold at the... Oh, flipping hell, they're so hot when you accidentally touch an insert. Oh, my head was started to wander thinking about other things. Oh, mother. Be careful. Hot things. Right. What was the question? Oh yeah, probably no dedicated video at the moment. I got a lot of other stuff to just sort out. Ouchies. I'm moving my website over to Shopify at the moment, and that is just a huge amount of work. Making sure everything works. Some of you may have received random emails that look like they're spam from me, because as I've moved my website over, I've had to import the orders from the old website to the new one. And then for some reason it thinks, oh, look, there's a new order. Let's just send out new emails. So loads of people got these really confusing emails that made no sense. So yes, that was slightly embarrassing. Right. Having one mouse for two computers is kind of a pain. So now we've got these two lots assembled together. We need to get this bit into this shape. We can ignore these things at the minute. These are the earth clip strap things that just link all the metal bars together, so we get this kind of nice earth structure, just as an electrical safety measure. But because they're clips, they can clip over the rods, so we don't need to put them in at this moment. What we do need, though, is these rods. And I forget what length they are. $500? I think they're 500 in both directions. Ooh. Yes. Nice and easy to remember. I think we'll move the heatset insert press out the way for now. We'll get a bit of the frame together, but we're going to need it back in a minute, I think. So I'll just tuck it out the way, because my desk is tiny, isn't it? So we've done some of the inserts, but we've still got literally hundreds to go. I'm sure I've counted them right, but it does seem a lot. So the next thing we're going to need is some M3x8 screws. We've got 200 odd of these. So again, we'll just take a bunch of those. Those, and then we need this big fat tube. This is the big fat tube of rods. So all of these rods are just kind of your standard linear rods, 8mm. And they are a little bit greasy, and I forgot that. I might have gloves on for this actually, just because I don't like the grease. Or we just could also sort of clean it down a bit. Right. So there's two short ones. These are for the idlers. We'll put those to one side for now. And then we've got to work out which one of these, which bunch of these is 500mm. The one that there's lots of. So there's two long ones, one short one, and the rest are 500mm. So I think those other ones can go here. It's going to be a while before we need those. 1, 2, 3, 4, 6, 7, 8. Those 4 can go away too. to make a different size version of this printer? This is a good question. As long as you keep the ratio the same, so the angles on the rods are the same, then you don't need to change the little joiners in the middle. But if you do, they're very simple. You'll have to make sure you find somewhere for the electronics to go. But most other things should just scale down pretty nicely, I think. So, we'll do lower set first. I'm just going to go wash my hands. Back in a second. Yeah, we're going to start with the lower set. And we're just going to measure the corner diagonals to make sure we get everything square. And then it'll be square enough. And we can fine tune it later on. Right. Screwdriver. So there's one little trick to doing the assembly as well. The bits that stick out the end are all like set depths. And if we get one of the end pieces which goes on there, we can use it to help us get stuff in the right place. So these are 20mm thick, and the spacer is 8mm thick. So the ones that stick out 28mm, we use both. The ones that stick out 20mm, we just use this. And that will help us get everything aligned nicely. So we've got those in the top, and then there's 4 more screws in the bottom. Okay, simple rod joiners would be easy enough to redesign. Yeah, they would be. You just have to measure the angle, and then you could type in the angle to the parameters probably, and it will just recreate itself. I'm pretty sure. So I've looked at some Fusion exported stuff recently, and it's kind of come in as dumb solids, but I'm pretty sure the way I exported this, you should see the whole feature tree. So you should just be able to go back to the bit where I put the angle in for the cross, change it to whatever angle you need, and it will just make a new part of the new angle. So for this, we should be able to just kind of stick these out like this, slam some rods in, job's a good one. Well, that looks like it's in the wrong place. How have I done that? Because the sticker's on the wrong way around. Oh man, I knew it would happen. You try your goddamn hardest and you still mess it up. I don't know how I managed that, because I even got the stickers. I checked the stickers at the start and still managed to get it wrong. Right. We have to have some extra inserts on this one. So that should go through there. That should go through there. That goes to there. That goes to there. This goes through here. This goes through here. And ta-da, we've basically got a frame. So that's front here, and then we've got top here. So that's the front, that's the side. The bottom one goes on the left here. So I've used 3 times, 3 extra. I mean, the fact that I can't do it right, and I designed the bloody thing, does suggest it could do with some improvement in that front. As I said, the original design was only intended to be made once, so for that purpose, it would have been absolutely fine, because as long as you can do it right once, that's all you need. But yes, now there's a kit, I shall see what I can do about improving that. I'll try and keep all the bond the same, obviously, and just modify the printed parts a little bit. Okay, so hopefully you can see here. My camera is just not that wide. So as you can see, that's all the rods in, and they just slide really smoothly back and forth wherever you like. But they do have a correct amount of sticking outness that you do need to get right. As I mentioned, 20 millimeters or 28 millimeters. If you look from the top, you'll see that this is 28. Oh, no, can't see. There we go. 28, 20, 28, 20, 28, 20, 28, 20. So you just start at one point and then alternate all the way around, and then you'll be good. And of course, half of them kind of match the other half, so it should be easy. So you start at the front left. Let's just double check that it is the front, because otherwise we'll get it wrong. Yep. That is 28. So we put on our 20, and we put on the 8. We get it right to the end, and we tighten the screw. You've got to be careful not to over tighten it, because the more you tighten it, the more it's going to force the heat insert out and bend the part and all this kind of stuff, which is why you need plenty of perimeters so you can screw it in without damaging anything. Now, because this one's 28, the one on the same block has to be less, so that has to be 20. So it, oh, why you no go in? Bit of an elephant's foot, I think, on this piece. We can do it this side, it's fine. So we get that to 20 millimeters. This one's a bit more difficult because it's the screws underneath. Again, just don't do it too tight. So that's 28, 20. So the next one round has to be 28. So the 8 plus the 20. Get it to the edge. $28, so the next one has to be 20, so we need to scoot this out a little bit. The next one is 28, so we've got to scoot this out a little bit. That was 20. This one has to be 28. It's not quite there. That's nice. No, the green parts are clips, so they can go on at any time, so we don't have to worry about those now, luckily. I mean, luckily. It was intended that way. It's not complete random chance. But those green bits are like a P clip. They're just earth clips, they can go on at any time. I tend to do them right at... I've only done it once before. But they're probably easiest to do right at the end, as you're doing the wiring. You could Loctite these if you wanted to, as long as it's not going to get all over the printed parts. So that's 28, 20, so that makes this one 28. Now this one might need a little bit of convincing, not very much at all, just to make sure that the final result is pretty square. That's 28, and the last screw. Nice and flush. $20. So let's have a quick measure and we'll see how close we got. I think my only tape measure is in the other room. Back in a second. This is the downside of working in two places at once. So if we measure from corner to corner, this is 636.5 millimeters. Across the other diagonal is 640 millimeters. So we're a little bit off. We can try finding out what it should be exactly. 639. It's quite flexible at the moment. Whatever adjustments you do kind of at this point, you're going to be adjusting them more later anyway. It's worth checking this. 364. 364. 364. 364. So the dimensions are right, it's just a little bit skew. But that's fine. We can use, when we put the diagonal rods on that go across, we can use that to adjust a little bit if we need to. But the lengths are okay. It's just a little bit squiff. Not a problem. There's also a thing called Permatex. That sounds like a classic American brand, that does. So what I did last time is now make the new frame, the next frame, basically on top of this one. Oh, I forget which one. It's going to be this inner corner, so it's this one. Inner corner, not those two. No, not the inner corner. So the way I'm choosing here, I know based on the orientation where the front is, and I know the inside corner because I know this is the front. The inside corner, which is this one here, this corner here, is where the support goes for the Z-axis. It comes up here and fixes in these two screws. So I know that these two will be for that, which means the only other one is the one I need for the rod. Hopefully, having said that, I've actually got it right. So did I put it right on top before? Probably not. I can just build it separately. We just basically do it the same way. Shove the rods through. And then use our spacers things to get everything in the right place. Right. So this one will start opposite to the other one. So it was, I'll show you. On the laptop screen. Close this measurement. Load in the second frame. Hopefully somewhere here. So where this connects, that 28 has to be diagonally the same as this one. So this 28, it's because that's where the crossbeam rods go on, and some sit on the outside of the others. And obviously they're offset by 8mm because they have a diameter of 8mm, which is why one is 20 and one is 28. So this one, which is 28, you can see it sticks out more. It sticks out more, the bottom one here. Oh, you can't really see because of the way Fusion highlights. But yeah, the long one at the bottom, the short one at the top. So 28 diagonally, 20 diagonally that way. So directly above it will be the opposite length. So we need a 20 here. That was probably a very long way of explaining a very simple thing. I'll see you next to 20. Comes 28. Next to 28. It's 20. And 28. Then we have 20 again. And 28. Good to hear you're excited, David. I am too, to finally be sharing the assembly process. Obviously, the first time I did this, nobody even knew it was happening. Well, a very few people knew it was happening. A little bit more. Lovely jubbly. Upper left fronts, we've got our arrows all pointing forwards. And then we have our lower frame goes beneath it. Bibbidi bobbidi boom. Ba-ba. Hello. Hello to India. The whole of India. So as always, there's a good way to do this and a not so good way to do this. Just going to look to see. The thing I'm thinking is there's a set space for these things. Yeah, we have this foot, this spacer, this thing, and then the gaps, the spacer in here. And we can use that to get the vertical rods all in the right place. So, hope someone's making a note of the assembly instructions. I kind of want to make some notes as I go. Sorry, this is going to be super annoying. It's really warm in here. Might take my jumper off. I've got some TPU constantly on the drying cycle. So it's heating up the room. But it's comfortable having this hoodie on, so I want to keep it. So, assembly step 1 is heatset inserts, HSIs for the Swiss cheese blocks. And then step 2 is the upper and lower frames. And then step 3, I think we'll do the feet for spacers. Because that will help us get, spilling things. As I said, by doing the spacers for the feet now, we can get the vertical rods in the right place, which just helps with all the things being in the right place, just generally. So I think we need to dig some parts. Oot. I didn't really organize this box right. Again, it was just to print everything and shove it in a box sort of scenario. So nothing really has a position or a place. It's just here somewhere. Aha. These are our feet spaces. And then we have some more of these little 8mm spaces. A 3, a 3, a 1, and a 1, is it? I think it's 2 and a 2. 2. That's a foot thing, that's a foot thing. That's a foot thing. It also doesn't help, right? Basically, all the parts are the same color. There's like one thing in black, one thing in clear, and a very small number of green pieces. But that's just the way I've done it. No reason you couldn't do it differently. I've just obviously gone for a strong RepRap theme, which are by no means required to do. We need some foots. Let's move these up here. Oh, try not to break everything in the process. This is so precariously balanced. Oh, that was lucky. So these are the feet. These are just standard Voron Trident style feet. So should be nice and easy to source. Bibbidi bobbidi boom. What type of filament? It's all Prusa ASA. Oh, I should have mentioned that as a sponsor. It's not the end of the world. Prusa obviously also supplied the filament. That's a weird thing about these sponsorships, just even remembering to mention them. I think this is the bolts we're using. Yes. I can't believe how well I've done with labeling all these bags and everything. This has taken me ages. So 4 whacking great bolts for these. And this, and this, and this. Oh, we should have some M8 nuts as well. Now, ideally, we'd put the rods through and make this whole cross assembly. But basically, threaded rod comes in multiple different pitch sizes. The normal is coarse and fine is normally specified if different. Specified if required, however you like to put it. But LDO accidentally sent the fine pitch rods. So I bought some from the UK just to make sure I had them. And they delivered them today. But they're absolutely disgusting. Like, I thought they'd still be just clean, but they somehow managed to get dirt all over them. I don't know how. Chucked them on the ground before packaging them up. So they're in their other room. I want to clean them first. So maybe normally we'd have the threaded rods and we'd do all that shenanigans as well. But for now, I think I'm just going to do the feet. Because these are M8 bolts, they can take a lot of torque, but don't, because you'll crush the parts before you, well, yes, you'll crush the parts. So that's one, and then we need to do one width spacer. So we need that through there, this on here, then this on here, and then you can see on there, there's like a little cutout, yeah, at the top there. So that needs to align with the threaded rod comes through, which in this is this hole adjacent to here. So we can use a bolt just as an example to make sure it's in approximately the right place. There's a bit of clearance, so you don't have to get it precise. And then that just goes on here. Bibbidi bobbidi boom. I think we need heat insert in there. So I've probably made a balls up there slightly. Yes, we need heat set inserts in there. Let's do those quickly. So anywhere a smooth rod connects to a part, we use grub screws to hold it in place. At least I'm pretty sure it's everywhere. Hopefully it won't be long before these ship out actually now. Most of the parts are here. We've had to get a couple remade, so they'll be a little bit longer. I won't ship out anything until everything's ready. But as you can see, the design is kind of done. I'm very happy with it. Let me show you this really cool mechanism here, because I'm really proud of how it works. It's super cool. So here, you see, it sticks out a little bit at the top on this one. It's sort of a prototype, but it's not by much. So you basically take this screw out here, and then this little container pops out the top. And in this little container is the extra counterweight shims. So you can adjust the counterweight, and then it goes all back in this nice little block, which sits delicately on top. And the reason it's quite clever is because it takes the same amount of space no matter how many shims you use, so you don't have to have some sort of adjustable container in order to get it to work. It's the little things, eh? Hopefully somebody appreciate how cool that design is. So this is a counterboard hole, which are a little bit more difficult to do heat set inserts in because you don't get great visibility. And it's even worse when you've got fucking great studio lights on and they're all pointing in the wrong direction. So most difficult for me. I'm sure you'll manage fine. Just don't be too keen. Okay. That's back down there. Right, let's put these back together. Yeah, you can adjust the counterweights depending on the soldering iron. I mean, VLMP Pro, which is that model, is designed, I mean, it comes with the soldering iron, so there'd be no reason to use another one. But even like the different models of soldering iron have different variations. How much lubricant and stuff you have on the rails will change the friction. The density of the parts, if you reprint them at a slightly different density, they'll sway slightly more or less. So generally, once you've set it up, it's like a one-time adjustment. You'll get it right, and then you won't need to change it again. But it's just Some people prefer like even just having it move a little bit faster or a little bit slower. So this is why we have adjustment. So that's one of each type of foot. That goes in there, that goes in there. Whoops, a daisy. Yeah, VLMP Pro will be shipped internationally. VLMP, we ship international already. Okay, so we've got 2 tool feet, 2 with spaces, like this, and 2 without spaces, like this. Have I put it in the wrong way around? Why do these look different? These look the same. Yes. What's happened there? Something's happened. Has one been mirrored? Are they a left and a right and I've forgotten about it? So this has this here. This goes on here. This goes that way around. Oh, there is a thing on both sides. There's a nut recess on both sides. I think I did that to make it symmetrical, and I've not paid attention. Silly me. So that one goes like that. This one is that right? I think that's right for that one. This doesn't look right. This goes this way, this goes this way, and that goes on the same side. So this goes this way, this goes this way, and that goes on the same side. Are they both the wrong way around or both the right way around? I think these are both the right way around. No, they're not. They're both the wrong way around. So can I switch them? Let me try and show you what I'm trying to do. I had forgotten, basically, that these pieces on the bottom have to be like opposite each other, like this. So they're sort of symmetrically opposite. So you have to get them just right to be in the right place, otherwise they won't make any sense. So that's right. Those go bolt to bolt, bolt to bolt, open hole, da-be-da-be-da. Okay. That's looking good. So you'll also notice if I measure here, this gap here should be 24 millimeters exactly. It is. And this one over here should be, I think, 16 millimeters exactly. It is. So you'll notice that 16 and 8, 24 and 16, both divisible by 8. One has 3 spaces, one has 2 spaces. So when we assemble the frame on top, it should work nicely. We don't need the upper frame just yet. Just take the lower frame. In fact, we probably don't need to assemble stuff yet. The next thing to do is probably preparing the Z-axis stuff, because that all needs to go in kind of at the same time. So let's just check the rod length. I think it's going to be 500 again. Yes, 500s. So we're going to have to pull these all out again to make sure we get the right ones. Or 500. And basically, what we should find, greasy hands. I should have, sorry. See, I don't want the computer mouse to get really greasy, because I think it will make the plastic go all strange and sticky and weird. So, front. So, front left is a tool foot, and it's this one. So this goes here, this goes through here, if we can get it in. We might need, oh, it's not going to help if the, I mean, sticker what's in the way, is it? Might need to drill these holes a little bit. Oh no, we're in. So this, I believe, should have 2 spaces. And then goes into here. And that should fit down there. Nicely done. It all looks a little bit twisted at the moment, but it's fine, I'm sure. One, 2, 3 spaces. And this foot goes like this. Then we turn. Oh, you idiot. Oh, I know what I should have done. Where I put those heatset inserts in, we should have put the screws in, because now we can, that means we can grip the rods. I forgot to put them in. So 1 on each. So wait, 3 on here, 1. Shoot sticks, there it is. 3. This goes in here. Now we can twist it around and hopefully not knock everything off the back. So this now needs to be the tall one, goes opposite here, goes on this side. Throw smooth roll through here. I think we just get a bit of friction at the very bottom surface. My Z offset was not perfect when I did these prints, so there's a bit more elephant's foot than I would normally like. So that's why we get a bit of stiffness there, but normally you could definitely make it so they were nice and smooth. Like, can we, yeah. 3, and then the last one goes here. Oh, I keep dropping them. I'm all fingers and thumbs today. I've lost it somewhere. One, two, three. That is right through. So that should all sit firmly on those feet. And as you saw, I don't really have to measure anything. Everything is just designed to go to the full extent and then lock into place pretty much. This is the basis of the frame. Now, we don't get a lot of rigidity from these, obviously, but that's why we have cross braces basically everywhere, and that makes the whole thing super strong. So, I mean, the next thing we kind of put on is the top, but we can't put the Z-axis in until, well, we can't put the top on words. Words are difficult. We have to put the Z-axis in before we put that top upper section on, the top upper frame. So we need to make the Z-axis assemblies next. So I think it might be time for a quick, like, 2-minute break. And then we'll come back and do some more heat set inserts, probably. Start building that Z-axis. We've got 4 matching assemblies of that to do, so lots to do. Yeah, we'll be back in a minute. Right. Is the audio a bit quiet, by the way, or is it okay? It's looking like it could be a bit quiet. Might try and shift it up just a tiny bit. Hopefully, maybe that's a bit better. Right. So, yes, Z-axis assembly. That's what we're doing next. See, this is maybe why it's not a great idea to assemble this just yet. Howdy, howdy. Howdy, folks. Sorry. Bad accent imitation. Naughty. Z-axis. Z-axis. I must remember how to Z-axis. I don't know how I've managed to use up all this space near me already. Let's put this up here. Put this over here. This down here. Anything but space for this frame here. Hopefully I can squeeze that up here as well. There we go. Hello, 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 and welcome back. Welcome, welcome, welcome. Hello. So, we're going to need a bunch of whopping great motors. Supplied by, of course, none other than LDO Motors. We need screws, and I think we just need printed parts. We need some bearings. Bearings, bearings, bearings. Where... Aha! We need these Oldham couplers. Those are some linear bearings. I don't know if we're going to use... I can't remember which ones I put in. I think 4LM8 LUU for the Z. Yes, we need these as well. Thrust bearings. We'll need the lead screws. That should be these. There's a lot of stuff that goes into the Z-axis. It's like the most complicated. Well, not complicated, but it's involved. It has many moving parts. Yes, we need those. The couplers. Don't need NOMI. Don't need drag chain. Don't need control board. Don't need sticky tape. Don't need pulleys. Oh, we need those. They're the lead screw nuts. Lead nuts, whatever you like to call them. Sticky tape. P-clips. Flange pulleys. I think I'm missing some bearings. Well, they can't be missing. They're here somewhere. Because I've ticked off everything on the list, so... It's just a matter of finding them amongst these many bags of stuff. And connectors, screw, haha, some bearings. That's a little bearing, that's a flange bearings. I think that might be what we've used. Well, there's other bearings here. Oof. Yeah, no, that's smaller, so that can't be it. Must be damn in it. Don't need these. And then we need printed parts. Chat's quite quiet today. Is it because this is new and I'm going very slow? So we've got these, which are the Z mounts. We've got that, which holds the bed. So there's kind of basically 4 of everything here. Not that or that. And then we have this. This is the top, like basically the idler goes the opposite end of this. You're working on your V0.2 build. Ah, nice. I haven't done a V0.2. I've done my 0.1 a long time ago. Well, it feels a long time ago. This is the thrust bearing mount holder thing, and that goes on here. Like so. This is the pretend pulleys. This is the bearing holder. That's 4 of those, that's good. 1, 2, 3. 1, 2, 3. 3. 4 of those. Oh, for the accent parts, by the way, the RepRap logos that I've done all in green, I've printed them all separately and I just glue them on with glue. As you do with glue, that's how you glue stuff. Rather than doing messing around with multi-material things, I've just done them separately. There's 4 little spacer rings and these go in here alongside the bearings. There's another one of these. There's going to be 8 of these in total because there's 2 for each. That's 4 of those. Ah, there's also a bunch of these, which is like a thing that fills the hole. I think I've called it a 3 to 8 millimeter boss. Z motor mount and this. Z motor mount. Z motor mount. Another one of these. Another one of these. Another of these. Damn, I forgot quite how many parts there are for this. How many are we up to? 1, 2, 3, 4, 5, 6, 7, 8. That's all of those. We're looking for one more thrust bearing holder. A bunch more of those. That's 6, 7, I definitely recommend organizing your parts. Sort them by size, if nothing else. That's 4 of those. 3, 4, 6, 7. There's one tiny little piece that I'm looking for. Aha, I see it. So let's have a quick walkthrough of the Z-axis assembly so you know what we're going to be working on. Right, I've got to switch this back. Laptop screen. Let's roll this back. Oh, it doesn't want to go back. Oh, because of this. Back to start. Thank you. So this assembly. So you can see this is where that lower block goes, like in here. So this mounts to this and then screws down into that lower block, and then the smooth rod goes up through here. In here you have the thrust mount. The thrust bearing goes on the inside of that, in there. You can see it here. Then you've got your coupler, the lead screw, the fake pulley, which just slides up and down. Then you have the bed mount, which is this main part. The Oldham coupler, decoupler sits on the inside of there. I don't know if I did much of a model for that. Yeah, it's just a block. And then you've got your Z-axis bearing, and that obviously lines up with that hole down the bottom. It looks like it doesn't, but it does. And then right in the top, you have this part, which is kind of just holds the top of the lead screw. So we've got to make 4 of these, which is quite a lot of work, turns out, right? Because there's loads and loads of parts. But I'm not going to rush, because I want it to be good. Hopefully you'll see, though, not too complicated, really. So what we're going to do is take one of each, or one set of each. So we need 2 bosses. One of these, which we don't need, the other 3 of these. We need a pair of these. We need a pair of these. We need one of these. One of these. One of these. One of these. Can we get a better view of this now? Is that better? Maybe I can just use this. No, this is where you need to look, I think. And then we've got 4 motors. Lots of the motors are basically the same in this build, which helps. They come with wires, some of them. Keep those, they'll be useful later on. Probably don't need to keep the whole box. I don't think I will, but I will keep the wire somewhere safe. Now, obviously it's important to put the right screws in the right place when it comes to these assemblies, because I have set which ones go where, and if you put the wrong one in the wrong place, then you might not have enough. We also need some filament. So offcuts of the filament that you've used to print the parts is probably perfect. Take that wonky bit off the end, and then take a short length of that. You won't need much. I think that'll be enough. I'm not sure. There's even 4 holes in these, and to be honest, you probably don't need all 4 holes. But we do need some glue. Just making a note of the alignment pieces and the glue for sticking them together. Because if I don't write them down, then they won't go into the bomb. And even now I might forget. What was I going? Glue. Glue, 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 glue. Do. Sticky things is glue. Where is it? There it is. So the idea here is you push this into the hole and cut it off. And it should leave just a little bit sticking out, which will allow you to push the 2 sides together, and they'll be nicely aligned and they won't come loose. Seems to work. Make sure you don't leave too much sticking out, otherwise they won't go fully together. So then we want to glue them and stack them all together. So I'm actually going to push this set to the side for a minute. I think I'm going to do all of these together, and then I can put them in one big stack and clamp them all with one clamp, as opposed to using like one clamp for each one. The holes are maybe a little bit tighter than they need to be, considering these pulleys are not even functional. Yep. There we go. That's 3. Oh, shoot. Right. These go all together nicely. They don't have to be too perfect, these, because as I said, they're not actually functional. So they don't really affect anything. They're purely there for aesthetics. So if you've not printed them quite perfectly, don't worry that it's going to ruin your motion and that sort of thing. It will have a very minimal effect, if any. This is probably not the best applicator for the glue because it's quite a fat nozzle. And you only need really quite a small amount of glue to hold these together. Anything that oozes out the side could be a bit of a problem, so try not to get too carried away. So now we just stack these all together, shove them in the clamp. If there's any obvious large amounts of glue, you can just sort of wipe it away. But hopefully if you're not being too overly generous with the glue, then you shouldn't get too much squeezing out the sides. Now we can leave that to the side and work on the rest of it. Ooh, We're on 2 hours. We can do probably another hour. It would be nice if I had a specific bill of materials for the screws I need here. Because I'm going to have to work it out. Well, we've got our trays and pots. So hopefully, between the two, we can get together what we need. So some M3x30s, I'm pretty sure, oh no, these are really long actually. These are M3x40. M3x45. Maybe let's see. I might have to check the bill of materials itself. No, not that one. Excuse me. See drive assemblies. Oh, we do need to do some heatset inserts. Yeah, in the bottom of these. Printed thrust bearings. M3x8s, M3x10s. 3x8, let's get those out. So it's M3x10, M3x15, M3x16. So I think M3x15, 15 and 16s are kind of both set to the same size because they're 1mm difference. So there's M3x16, M3x15, both the same. M3x25, 3x20. No, I don't know what's happened to these M3x40s. M3 by 50. And we've got 4 M3 by 45. But neither of those are M3 by 40. See, this is why we do this. Because I think I might have missed those when I was counting the parts. And aha! We're saved! This is weird that you can't see my face, but whatever. I need a wider lens. Does anybody know of a good wide lens for a Panasonic GH5? M3x40s, yes. The reason I didn't spot them is because they're in black. Because I didn't have them in a shorter length. So M3x40. Don't think there's any M3x20. No. M5x40, no. M3 washer, no. 3x30, no. 45, 50s, no. M3x8, M3x10. Oh, I didn't find the M3x10. I'm surprised I've used M3x8 and the M3x10, but it is what it is. M3x10. Right, those go here. I'll just stick those in bags that at the moment, I think. Hello! Welcome. Welcome one and all. Do 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 do. Let's get this heating up. Just a reminder, don't forget to hit the like button. To likey. If you want to leave a donation for the Sanjay Mortimer Foundation, you can do that via the link below. The whole printer is available open source. And thank you to the sponsors, LDO, E3D, Jo Prusa, who's paying me to do the build, and Prusa for sending across the film. I think there's like 200 and something. So quite a lot. A lot of them are kind of on brackets for wiring. So it could be possible to use less. But they're not that expensive. It's like, what, £8, £9 for a bag of 100 of these M3 sized. Oh yeah, that's just the M3 size. There's a handful of M5s and a handful of M4s as well, but not many of each of those. I find them really quite nice to do. They're very satisfying and they give such a good finish. Right, that's the 8 we need for this. I think a majority of them actually are going to be on the frame. On the electronic bracket things. Because I've just made these like clamps. And they use 2 on each one. So end up using quite a few. Ah, you can see me here. That's good, isn't it? Let's change that. VLMP is your friend. There's a lot of time just doing heat sets. Well, it's a printer build. It's designed to be a good build, not a good printer. That sounds awful. That's not quite what I mean. But it's more of a printer for builders than it is a printer for printers. If that makes sense. I mean, it's a printer that prints. But it's a printer for printers. A printer for builders. Right, let's put 3 of those back over there. Let's move on with this first little subset of parts. So, we should manage these M3. Let's just double check their length. This isn't the best way to do it. Yeah, I think these are all M3 by 16. So hopefully. So for motor orientation, in the assembly they're all the same, as in the CAD, because I've just used the same assembly 4 times. But there is an optimal way to put this, because you want obviously this to point really towards the electronics. And in some cases, like if you made this way around and the electronics are over here, it's the right way. But in the one in this corner, it would be this way round, and then it would need to go like this way. Does that make sense? Probably not. So yeah, stuff and things. We need this bit. So we need thrust bearing. Where is my thrust bearings? So these thrust bearings are of similar, although not identical design to the rat rig ones. In fact, now that I'm looking at them, they're more different than I expected, but they should be just fine. You basically put them in a little stack, so you have a base plate, and then you have the middle bit. You have a top plate. Oops, it is like so. And that sits in a little stack, and that's a bearing for force in this direction. So that goes in here. Should just sort of sit flat in there. Although it doesn't actually need to yet, does it? What we also need is these. Apparently they came in a bag of 5. So don't need one of those. We'll just use the remaining 4. But they're nice black ones, which I quite like. Don't they look smart? Hopefully they work as well as they look. Lead screws in there. Bearings. Okay. So we should have this on here. 3 M3 by 16s. This is the one bit I'm not certain about because I changed the screw length. So we don't want the screw to obviously bottom out on the motor. We want it to grab all the parts together. before it bottoms out on the motor. Oh, but we do need to get the screw to the motor. There we go. So in here you'll see a very small gap, which is what we want. And then we put the base plate up. So you want, there's one side which has a little kind of ring, whereas the other side is flat. So you want the little ridge facing upwards. Then you put your balls in. Then you put the other one on the top. And then we put the coupler on the top of that. That holds the whole lot together. Very handy Andy. So if we try and consider where we're putting this, so this can be front right. Maybe we can do the other ones of those now. Yeah, I'm changing the order in which I do things. As I said, I've not, because there's no instructions, and I've only done this once before, and it was a few months ago. I don't have a set specific order in which you must do things. I was thinking just now that maybe we do like a whole stack, but I think in order to get these connectors facing the right way, it's going to be easier to do them all at the same time. That way you can make sure they're all in front of you, and you don't do it in a weird way that's not useful. So motor's out, everything else can go away. Make sure to keep the wires. You need the wires. So bring our other watsits of these over, other watsits of these over, and our clutch bearings and our couplers. So front right, front left, we want facing the back. This one here we want facing inwards. And this one here we also want facing inwards. That's going to go there, so that's going to go in that direction. And we want one of these on each. I'm surprised there's only 39 viewers, to be honest. I was kind of thinking there would be more. I mean, I know I don't live stream that regularly, but I did think there would be more, I'll be honest. Why is this not going in? Yeah, again, it's just slight elephant's foot. My Z was a bit too close. So all the parts have a little flangey bit, a little elephant's foot flange bit around the bottom, which is a little bit annoying, but it's only very, very tiny. I need to do this one too. Welcome, we have a new member. Thank you, Nuno. How long does it take to build this printer? You know what? You're going to find out about basically the same time as I am. because the first one, obviously, it was kind of done as a one-off. I didn't really build it just start to finish. I didn't just sit down and build it. It was kind of build a bit, take a bit apart, change a bit, put another bit in, make a little modification, do another bit. I didn't do that too much. So my guess is going to be 30 to 35 hours. But I can't be certain. And I just realized I should put some grease on these. So we shall do that thusly. Ooh. Bit of the old super lube. So I'm basically just going to lube on the actual bearings themselves. It will spread around naturally, I think, mostly. So I'm not too worried about spreading it everywhere myself. And then we've got to do this one, which I've already put the bearing coupler on. That's 1, 2. Oh, what am I doing the top one for? I think I tightened the top one on this, didn't I? Yes. Fucking Egypt. Right, so that's our front and rear motors. Next, I guess we can just do these little bearing holders. This should be quite quick. So there's 4 linear bearings. You could use the brass ones. I don't think I have enough to do them everywhere. So we're using these. It should be all right though. Z is never going to move very far. In the kits, I'm hoping to have some kind of quite nice bearings. These are kind of generic branded. Just because I wanted to test the bomb that I've linked online. Obviously, you're welcome to spend more on bearings if you so wish. I'm not trying to get all the oil off the outside because they can corrode the outside of these. Obviously, it doesn't matter in terms of performance, really. But it can look a bit naff. So ta-da! Easy peasy. Next, these are going to attach to these. So I probably should have tested this before doing the live stream, but hopefully these threaded nut pieces match these lead screws from RepRap. Yes, they do. Thank goodness. I thought for a minute they were not going to. So that's those. And then also in here, we need the Oldham couplers. These are particularly expensive ones. These are the RepRap ones. They have a really good slide to them, as in they're very low friction. But they're like 19 euros each or something like that. Yeah. These are not actually the official RepRap ones, and they're not as good. I should have just bought them from RepRap. At least I don't think I did. Did I get them from elsewhere? I can't remember now. These ones don't look quite as good as the RepRap ones, though. Yeah. So there are little brass ones as an option. I think I put that as an alternative link. They're like £3 as opposed to 19. Depending on how much you plan to use your printer versus just enjoy building it, you may want to consider the cheaper option. This is not the way round this goes. This goes like this. I forget what screws we need though. Ah, I think I have forgotten screws for this. So I think we need 2, 4, 6, 8 extra. Because there's none in the CAD, so I'm assuming I've probably forgotten them. Yeah, I'm pretty sure the ones I had from RepRap, the brass was shiny, and here it's kind of not. So I'd probably recommend getting them directly from RepRap. These might have been, I just don't think they were, I'm not sure. I think this length is fine. Yeah. So the way you want to do it is this. Oh. This bit needs to stick out. It looks like it would be nice to put it in, but if you stick it in, then the coupling can't do this offsetty thing that it does, right? So you need to make it sure it sticks out. That is the way. So we stick that on there, and stick the rest of it up in here. 2 more screws, hold it in place. Oh, rats. Oh my goodness. Put it on the screw fit. Oh my goodness! I've got a very small amount of grease on my hands. It's just stopping me holding anything. So that should go up through there. And allows it to move nicely around. Although some lubrication would probably be a good idea. The ones with RepRap I don't think I did because they were very, very smooth without it. These ones are not quite as good quality. I think they're going to be fine. But the RepRap ones were really nice. So There we go. Get this back in here. We won't lubricate these now, but they will need lubrication once we get the printer going. So we just need to do more of that. Get a little bit of lube in here. I'm now getting loads of grease on my hands. I've really not been very careful. This is another area where you might want to consider using some Loctite. The screws could be quite difficult to get to later down the line. I think in most cases you'll be fine, partly because you're screwing in a plastic piece which can help keep things locked together. Oops. I've just realised, I think I set these to be M3 by 10 and I'm putting in M3 by 8. M3 by 8 is not very long for this. Yes, they should be M3 by 10. Where's the M3 by 10 screws here? So we need to take these ones out as well. You just don't get very much engagement with the M3 by 8. It's like maybe 2 turns. Whereas this is more like 6, at least. Let's get some lubrication on. No, let's screw this in first. Right, we've got about 20 minutes left. I don't know if I'll be able to finish getting all these lead screws, this Z axis done. But we might be able to get at least to a point where we're ready to install them, even if they're not completely installed. There we go. That's in. That's moving nicely. Now we can get rid of this. So now we have to secure these to this. So this is obviously the bit that does this, and this is the bit that does this, and they need to do this, so they do this together. So they just slot on, and then some screws will hold them together. We just have to find the screws. According to this, M5B25. Hopefully, it's this then. M5x25. We also want some M5 washers. Yeah. And some M5 nuts. So the M5 nuts are actually going to have two purposes on these pieces. Firstly, as I just mentioned, these holes for holding this piece to this piece. And secondly, where the bed secures in here, we need to press some nuts into the back there. They could be heater inserts, but they're not. They're nuts because reasons. Mainly because that's what they were on the original Darwin, and I tried to change as little as possible, sort of. Hopefully these will go in quite easily, but I wonder that maybe they won't. Don't have to get them all the way in, just to a point where they're not going to come out again. And then when we tighten the bed in, it will pull them into place. That's those three on there. Don't forget, if you're interested in getting one of these, there's two options. Either the LDO kit, which may or may not be a thing, we don't know for certain yet. Or you can self-source yourself entirely. The bomb is all on printables, as is the full 3D model. You'll need Fusion 360 to open the full 3D model, but it is all there. So you can do with it pretty much as you wish. It is open source after all. You just have to follow the license. Right, that's that. Now we've got to do the securing them together. So the reason I did that first is I was using obviously that screw to pull them through, but once we've assembled it, we won't have that screw available because there's only 8. 2, 3, 4, 5, 6, 7, 8. 2 in each, that's all. Also got these M5 washers. I believe I will have put one both sides. Yes. So we go screw, washer, hole, washer, nut. Screw, washer, hole, washer, nut. Ta-da! We can tighten them at a later date, probably. Screw, washer, hole, washer, nut. I've probably gone really quiet, haven't I? I feel like I have to concentrate quite a bit because there's obviously no instructions. It takes a little bit more brain power to sort of plan out the next moves. Oh. Screw, washer, hole, washer, nut. Screw, washer, hole, washer, nut. Oh, shit. Screw, washer. Right. I think what might be a good idea is to do some tightening now, just so the nylock nuts definitely won't fall off. But we don't want to lock anything in place until it's assembled onto the printer. Because this will kind of set the correct distance between the bearings and the linear rods. And if you don't get it quite right, then it will just increase the friction, which we don't necessarily really want. It could probably cause like print artifacts and stuff as well if it's too far out. Just a few turns, still nice and loose. So the actual thing itself, you can kind of see maybe. It slips in and out, and it can sort of rotate a bit as well. So that gives us our adjustment, which we'll need as we continue the assembly. Then we have these top pieces. So these should be quite easy. Hopefully, we grab the flange bearings and press one into each hole. One. Two. Three. And four. And then we put a little spacer on the top. And there's those ready to go. Now, we're pretty much ready to assemble this lot, I think. The first thing I'm going to do is attach these to the underside of the top. So, oh, that's not a good idea. How did that happen? Oh, oh, no, you piece of ass. Oh no, now I'm breaking everything. You sit on there. You clip in there. Good. Right. So, if you remember before, we labelled them all. Upper left front, upper right front. So these go, basically, slip under here and have to be screwed up from the other side. So what we're going to do is flip the whole doobly over. And now you'll see what those heatset inserts were for. And I'm pretty sure that's an M3x8 on each one. Yep. Well, two M3x8s on each one. That should line up perfectly with the hole below. How are people's thoughts on the assembly process so far? Obviously, it doesn't have instructions, which I acknowledge is potentially a major challenge for most people. Admittedly, I rarely take on a project that doesn't have instructions. But what are the general thoughts? I mean, about this being the instructions, maybe about the general complexity, about how easy it looks to put together. I'm interested in what your feedback is. That's those. Then we put this to one side, somewhere there, and bring this back. Lower left front, lower right front. We had our motors correctly orientated so that we face the things in the right direction. So now we're going to move our stickers because we don't really want these to be on the build when we finish. So we're just going to move those out of the way. We do need our long screws, so those M3x45s, those are going to hold our motors into place. So that's what we need now. And these trays are not quite big enough for those screws. They can go in this pot. So no, come on. I've literally put the motors in the specific corners they need to go. So the wiring needs to point to the back middle. That's why you were doing them in this orientation. So this just slides over here. Ta-da! Isn't that just flipping amazing? So satisfying. And then you put the screw through this boss. And that just stops the, because we're using oh, this is a bit tight. Because we're using an M3 screw, but we've got those large 8mm holes, this just stops the whole thing putting straight through the hole. I'm going to get the ball head driver. I think that'll make it a little bit easier to do these, because they're kind of off the edge of the table. Ooh. Being careful not to destroy your setup as you go. Might just... got a little knife? Got a little knife? I need to get one of those CNC Kitchen deburring tools. I have them in the other room because I sell them, but I've not purchased one from myself. There we go. Nicely done. Nicely done. That goes in there. There we go. And that's a motor mounted. A motor mounted. A mounted. Yes, Adam, well done. Let's put all these motors on. That way we know they're in the right place and I won't get confused as I start spinning the whole frame around. Not so complicated until now. Are you saying that now it looks more complicated, or just so far it looks okay? Oh, you see, this is the slight problem with the spinniness of the frame at the moment. It gets better the more you assemble. Good work. I'm glad it doesn't look too bad. Because I think the hard part is over. The hard part is really that first step. Once you get past that, yeah, once you get past that first bit, it's really, I think it's pretty easy after that. It's kind of obvious where things go. Everything just sort of sits in its place. Oh. Oh, just whatever you do, don't drop parts like I've just done. There we go. So that's those in place. Now where's our stickers? There they are. They're pointing forwards. So we'll have that round that way. "3D printer!" You can put one of these in each. Need our things what we glued together earlier. They're probably dry enough. If I'm like instructionally wise, I'd leave these a little bit longer to dry fully, because they're not quite dry. It's not going to have a big difference on performance, as I mentioned earlier. But for sake of demonstration purposes and doing a live stream, I'm just going to go ahead and assemble these right now. And then after that, we can put these carriages on. And you start to see all of a sudden, we have what basically looks like a 3D printer. Yeah, I'm going to have a look at how I can improve the printed parts for those corners. Because now having done it myself for a second time, I thought I'd be able to get it perfect. And even I messed it up, so that tells me that it definitely needs a little bit of improvement. I'm going to try and keep the bill of materials exactly the same and just adjust those corner blocks a little bit. See if I can make those a little bit better. So that's that lot. And then we've got this top frame, which basically just now sits on the top. As, you know, top frames tend to do. So it should just sit on there perfectly. It may need a little bit of encouragement if the printed parts aren't printed perfectly printed parts. Just some gentle encouragement with a small hammer. And I think that's where we're going to leave it. This one definitely needs to go down a little bit more. There's a way to get the Z height of that top frame just right. But we'll leave that for the next video, live stream. You know what I mean. How's that? Ta-da! That's gone rather well, hasn't it, I think? And it's just past 3 hours. I think that's a pretty good amount of frame assembly for 3 hours work. Considering, as I've said for the 100th time, there are no instructions. Pretty cool, eh? And already, I mean, it's not super stiff, I'll be honest. None of the cross bracing is on yet, and that's where all the stiffness comes from. But it does feel like a 3D printer already, so that's always nice. So that's going to be it from me today. Thank you to the sponsors, LDO for sending parts, E3D for sending their hot end, the Revo Voron, and some nozzles, Jo Prusa for asking me to do this, and Prusa for sending all the ASA filament. Lovely stuff. Don't forget to leave a donation for the Sanjay Mortimer Foundation via the link in the description. That's a link to PayPal. There's no affiliation or anything, like, obviously it's a charity, so donate if you want to. That'd be great. Other than that, thanks very much, and I shall see you in the next one. Goodbye. Goodbye, 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 goodbye.